Thank you very much. Wonderfully moderated. I actually would like a pair of those socks, Phil. If you can send
Ah,
them to me, I quite like those octopus socks. They were very cool. It was a really it was a really good panel because I think there's a lot of common themes in each panel today, and I think it sort of comes back to technology and how that decarbonizes, but what technology helps us to do that, and how we're going to deal with all this extra energy demand and everything else. So it's interesting when you sort of have different viewpoints from, whether it's an energy company like you, whether it's a technology company like Salesforce, or everyone brings their own sort of information to the mix. Let me
mhm.
ask you a couple of questions because I'd like to the whole point of me doing a closing remarks with you is just to go over a couple of things from your perspective. Um, how will the grid cope? Obviously, with all this extra, I'm talking about a renewable grid. How will it cope with
Yep.
all the extra sort of work, TVs, electric heating? Because, I see everyone's talking about extra usage, but you'd also talk about this intermittency of renewables. So what's going to happen with that actually?
Yeah, I mean that's a lot of what we've kind of been trying to cover on that panel session just now, and it's a lot of what we're
Mm,
doing a lot with the technology that we're kind of inventing and creating and licensing to other energy suppliers all around the world. I mean, the grid is already coping with 40% of our generation coming from renewable energy. Today, I was looking at the statistics, and we were hovering around about 25% solar, which is brilliant. That's free
mm.
energy. You know, there's the marginal cost of generated electricity is very very low, and the grid is coping. We haven't had any kind of brownouts or significant issues on the grid with that level of renewable energy, so we can already cope with it now. You know, there was plenty of news warnings and alerts and all the rest of the last few years. Will the grid cope with it and all the rest of it? And actually, it's already proving it is. And I think that's because the industry is kind of working together. You know, you see
Yeah,
connections between UKPN and Scottish Generation Networks and us and other energy suppliers all trying to work on this problem together because we want to get to a renewable grid. But that session that we've just had talking about AI, machine learning, IoT, as things in the home, so our EV chargers, our cars, our heat
mm,
pumps, and the heating solutions, solar battery inverter systems, things, all of those are becoming online. And that gives us potential to connect to those and work out what the best way is to manage those. And so how to help the grid work in the best way. So it's going to happen. I think we all know it's going to happen. That conversation was fascinating just to hear so much
yeah, it
kind of
was.
agreement, but all the different perspectives across all parts of the supply chain, from Hitachi making things to the Salesforce and the sales making the tech to balance it, to the grid network providers that have got to cope with this kind of chaos. It's a chaotic world that we're going into, right?
Yeah, it is. I mean, it's funny because I've listened into every panel today, and there hasn't been a lot of controversy or arguments. And I think it's what you just said there. Everyone's sort of in agreement that you've got to work together, whether it's utility or vendor and vendor. I think everyone knows that they've got to get to that point. I was told something the other day, which is I didn't know how to take it, that gas boilers will be obsolete in 6 years, and we're just going to focus on heat pumps. Now, I don't know how credible that is, but obviously, how do we get from a cottage industry to a scale industry when it comes to heat pump rollout?
Oh, well, I mean, yeah, the government has set a target kind of in the future home standard. We'll get off gas and all the rest of the next few years. So that will happen. You know,
Mm.
there's talk of hydrogen in the mix and all the rest of it, but it's just so inefficient to be generating hydrogen to put down the gas pipes, and all the gas pipe replacement, entire network supports this and all the rest of it. So yes, heat pumps. It's something like about 30,000 are installed a year today. Government set a target of 600,000 a year by 2028. That requires the manufacturing to come up, the manufacturing volume. It requires the installation engineers to be able to do that. And you probably saw in one of the panel sessions, I've done it a couple of times, and I've held up and said, actually, I'm not sat in a house.
I thought you
I'm
were going
in
to say
a
you're on another
laboratory
planet or
here.
something. I'm actually on Mars or something like that. I was like,
No, so this where I'm sat today is our research centre in the centre of Edge of Slough. It's an
mm,
industrial building, and we've built two houses inside a warehouse, and there's an awful lot of laboratory equipment. So if anybody's heard background noise, that's what's going on. Is more construction of laboratory equipment and things that's going on here. And this centre is designed to be able to both research and experiment with heat pump technology, and also to train engineers. So I've been walking through, chatting to some of the engineers here today that are learning how to install heat pumps and the wiring, all the plumbing work, and so on that goes into that. And what we're doing is training 1,000 engineers a year here. Those are full-time employees. This isn't other companies. We are training up our own engineers to drive that rollout. Some of these are also looking at solar battery install systems as well. So that is coming out of this centre too. And we've acquired a company in Ireland called Red, that's a heat pump manufacturer, and we're investing in them to be able to increase the manufacturing output that they can achieve as well. So you probably wouldn't have imagined that from an energy retailer previously, particularly one that's only 5 years old.
Unbelievable. Yeah, I know.
It's vital for us that we kind of drive this market, really. We need to get off gas and get all these heat pumps out and installed. So what better way to do it than buy, invest, and train?
It's very good to hear. It's encouraging to hear as well what you're doing. It's quick work and it's innovation at scale, isn't it? You've got to just do things very quickly. I don't know if Marja or someone mentioned this earlier. They was talking about let's just go quick. We can fail. It doesn't matter. We've got to do it though, because I think if you're constantly cost conscious or you're conscious of making a mistake, we're never going to catch up to that point where we're going to reach those goals. I think for 2035 and 2050, you've got two separate goals as well. Final question: why do we need half-hour energy management?
So I mean, do we or don't we? So at the moment, smart meters give us half-hour data, and that allows us to do
Yeah,
tasks, smart tasks. So go faster, intelligent octopus, agile, and so on. Half hour is probably the smallest time period that an average customer will be able to cope with and say, okay, I can 48 half hours a day. That's actually still quite a lot of data to look at.
yeah,
Um, but actually, it's not enough when we discussed on the panel just now. When you want to manage assets on the grid, you're working at a kind of
yeah.
a minute kind of level as to how much consumption is going on and how appliances are working and how the energy is being generated. I mean, if you ever get a chance to look at the solar output of a solar system or a wind generator, it fluctuates dramatically. So one of our tariffs is Fan Club, where we give customers that are a member of Fan Club, they're members of a local wind generator, and they can see the real-time data. It updates about 30-second interval. And you can see the output of these. They're small wind generators, about 500 kilowatts production. And it will swing in 30 seconds from 500 down to 400 and then back up to 500. There's such a rapid change in the output of solar generation. Or similarly, if you go and look at a solar system. So in Swansea, there's the Active Building Centre, and they have a whole monitoring dashboard screen set up, monitoring the solar that's on the rooftop of the building. It's quite a large solar array on the building. And you can see the solar generation as the clouds go over swinging by 50%. It's such a dramatic change.
That's
And that's
incredible.
why it is. So I mean, that's why when you look at moving towards lots of wind and lots of solar, that's very variable on the grid versus a gas power station or a nuclear power station or a coal power station where you burn stuff or atoms crash into each other and you get a really nice really steady flat
Yeah,
kind of slight drop and a slight rise versus doing this. But I mean, there are averages. You've got a large wind farm with 20 or 30 wind generators offshore and whatever, and there's a bit of averaging going on across that, and same with solar. But I mean, solar in this country is not huge because we don't have the day such as today. It's a beautiful sunny day.
yes, I was going to
It's
say.
impressive to see we're at 25% solar generation in the south.
Oh wow!
It's good.
I thought it'd be high, not that high, but that's high.
Oh yeah,
Yeah, I mean,
yeah.
it is interesting because I think there's a lot of conversation today about hydrogen, but obviously using hydrogen that is not, affecting the environment. So I think you can do so much with green, but then you've got to also work with blue. You've got to work with other colors to make it scalable. And I think that's a bit of I think a quandary as well within the industry.
Yeah, and we're tending to focus more on hydrogen for aviation, industrial, and transport, where it's much harder to come off gas for various reasons in those industries. Putting it into the gas network for heating and for hot water and cooking and so on. When you've got the electrical technologies such as heat pumps or whatever else, why would you even do that? The inefficiencies of converting electricity into hydrogen to then push it down the pipes, which has got to be modified and all the rest of it. I actually call a heat pump an energy generator. It's actually generating energy. So if you put a kilowatt hour of electricity into a heat pump, you will get 3, maybe as much as 5 times the amount of energy out of it. That's called the coefficient of performance. So a coefficient of performance, 3.5 to 5 times the heat output of the electricity you put into it. Because what you're doing with a heat pump is drawing heat from the air. So if you stand in front of a heat pump that's running, you will find the air temperature flowing out of the front of it will be 4 or 5 degrees lower than the air that's going in at the rear of it. That's free energy you're drawing from the air into that heat pump, and hence, because that's free energy, then it's got a coefficient of performance of 350% to 500%. It's a generator of energy in that sense. So if you've got a heat storage unit like phase change material or a hot water tank or whatever, you are storing energy by consuming a lowish amount, a kilowatt hour or 2 kilowatt hours of electricity. Now, that's far more efficient than trying to convert electricity into hydrogen to burn it in a combi boiler, which has an efficiency, as you only at about 80 or 90% efficient or whatever, to then provide heating. Massive difference. It's kind of like a no-brainer for us, at least.
I was going to say it's huge difference. No, it's huge difference. I think it's these conversations you can have probably for another 3 hours or something. It's interesting because everyone has their own opinion. It's good to see, obviously, throughout the day that we're going into the right direction. And I must say, Phil, thanks for moderating that panel. And once again, thank you for joining me on this. I really appreciate it. I think what you're doing at Octopus is wonderful, and especially, obviously, I opened the day with Lucy Yu from the Centre for Net Zero as well. And I think it's wonderful the work that you're doing there as well. So, Phil, thanks for joining me on Closing Remarks, and I hope to keep the dialogue going.
Yeah, I'll get you some socks. Thanks very much, Adam.
Thank you very much, Phil. Well, it was a wonderful day. I think it was good to get different viewpoints from the utilities, but I think it was really interesting to get associations, tech companies, and it sort of all mixes together. I think what I learned from today is the essential element of technology and sort of decarbonizing this industry. I think is absolutely paramount, especially with the interviews I've had as well, and some of the panel sessions. And it's really, really good to see some fantastic collaboration. Phil just talked about it just now, but having Octopus work with Centrica or these sort of utilities working together, these energy networks working together, all of the technology vendors working together to actually get us to a goal is really, really encouraging to see. So it sort of underlines the significance of collaboration within the sector as well. My takeaways probably today was really that it's collaboration more than anything else. It's really good to see companies and organizations collaborate. And I mentioned this to Phil, it was quite strange to see not so many opposing views, but there was a lot of agreement with everyone on a panel, and that was really refreshing to see when you have competitors or people that are not traditionally working with each other actually agree with each other. So it was a fantastic day. I really enjoyed it. Really thanks to everyone who contributed. Thanks to everyone who tuned in to the event as well. We are back 9:05 tomorrow morning. We've got a brilliant day tomorrow. It starts with a Q&A with Iberdrola, Alejandro Macho Roca, who's head of digital strategy for Iberdrola. And we've got some really, really strong discussions tomorrow, especially on sort of elements to do with policy and to do with change management and people management. So thank you very much for joining today, and I look forward to seeing you tomorrow.